All right, so let's go start our 2.3. It sort of starts out with definitions. All right, y'all, so 2.3. Let me pull it up just a little. Deals with finding domain and range. So I'll give you definitions that I use for domain and range, and then after a few problems, I'm going to show you how to find domain when we're looking at a function, okay? So for now, our domain is what we call a set of all x values. It's also known as the independent variable. So that means when it comes to the x-axis, we can pick any x's we want to, okay? So our range would be the set of all y values, and it's known as the dependent variable because the values for the range depend on what x values we put into it, okay? So the set of all y values, and it is a dependent variable. So with functions, you can figure the domain is all the inputs, the range will be all the outputs. Okay, you put a number in and then you get that number out. So when we talk about our domain and range, we use what we call set builder notation. So that's when they use our curvy little parentheses. So I'll put all my x values in here, separated by comma for my domain. When I do my range, I'll put all my y values in here, separated by comma. All right, so I'm going to pull up the Math Lab problems for 1 and 2 and show y'all what kind of questions they're going to ask you. So let me share my screen. All right, so y'all should be seeing problem 1 now. And I'm going to sort of let y'all answer these if you can. So they gave us a graph on the right side. So let me make that bigger for us. All right, so can y'all see that pretty good now? That graph with the dots? I had a few check in. So y'all, the first thing they want me to do for A here, they want us to find f of -5. So what they really want me to do is find the y value that we get when x is a -5. So y'all got any guesses? So let me pull my chat up.
+4.
Okay, so let's see. We're gonna go on the x-axis. We're gonna go over here to -5, go straight up to that dot. And that definitely has a y value of 4. Good job. So y'all, we're gonna put 4 in on that, check that answer. And it's gonna give us our second part of this. So the second part, they want the domain. Now notice they gave us the parentheses already. So all we got to do is put in our numbers and separate them by a comma.
So literally, is that just 4, -5 then?
Well, what they want is the whole domain of this graph over here. So they want all the x values of them graphs. So we got what, 1, 2, 3, 4, 5, 6, looks like 7 points. So what I need is 7 x values. So let me start y'all off.
0.
The furthest left point that y'all see has an X value of what?
Oh, -6.
-6, put a comma. To the right of that,
-5.
and it looks like it's going on down, right? -4 is next. -3 at the point down there. And then although the graph goes up to the right, my X values continue going down to what? -2.
-1.
Uh-huh.
And
0.
0.
And then 0 would be my last X value. So that's all we was worried about on that domain, okay?
Can I ask you a question? I'm sorry.
I hear you.
It's about point. It's about A. I'm trying to figure out how did you get 4 again? Can you show me one more time?
Okay, so think about this. For number A, they gave me the X value of a -5. So you're gonna get on this X axis and go left until we get to -5, right?
Mm-hmm.
Now go straight up and hit that dot.
Oh, okay. Now I
If
see
you
it.
look
All
to-
right.
If you look to the right, what's that Y value?
It's 4. I got
Yeah,
you.
there you go.
Thank you.
Mhm. Okay, so we're ready to what? Check this one, right? So we check our answer and then we're gonna move to the next. Now, this one says find any X values for which f of X equals 3. So what they're asking us is what X values of these 7 points have a Y value of 3. Because remember, f and X and Y are the same things on these graphs, okay?
-4.
Next to
So negative, okay, so negative, what y'all would say?
4 and -2.
So -4 is definitely, and then let's see, -2. So if you look at -4, y'all, they're right. You go up and that point is sitting at 3 on the y-axis. You go over here to -2, go straight up, that point is also at 3. So this one you just gotta put in the -4, comma, -2.
I'm confused. I'm sorry. Because I don't, I hear the word you're saying, but when I look at the problem, I don't see any reference to Y, to the letter Y. So when it says X values, I thought that would always be the horizontal left or right,
Okay, so let
which
me,
we,
I'm gonna fix y'all real quick. I'm gonna go back to my paper, okay? All right, so let me go to my paper. All right, so X-axis, 1, 2, 3, 4, 5. -5 down. I'm gonna go left -5. And then up 5. So I'm just gonna put me some random points on here. And then leave one more right. So then, okay, so y'all were good with me on the domain, right? Domain was the X values. So if I look straight down, that would be what, -3. So let's do our domain. So -3, that point is at -2, -1. I got a point at 0 on the X. Over here at 1 on the X, 2 on the X, and 3 on the X. So y'all are good on that stuff, right?
yeah.
Okay, so let me ask you this. What value do I get for f of 1?
Oh, I'm not going to be 1. Yeah,
no,
it's 1, 1.
Yeah, because see, there's the X value of 1, that's what we're putting in, right? So since I'm putting the F value of 1 in, I look at that dot, at that X value of 1, and it is at 1 on the Y axis. So here, what X values does f of X equal oh, let's say 0. Now, here's the thing. I got a Y labeled on this axis, right? It can also be this. But we just use a Y here because when we want to do ordered pairs, we got an X coordinate and a Y coordinate. But y'all, f of X and Y is the same thing. So when I'm down here saying what X value has a f of X equals 0, that means what X value has a Y value of 0. So now remember, my Y's are these horizontal lines, right? Like 0 would be there, 1 would be there, 2 would be there, 3, and so forth. Although we got these little tick marks here, remember, they go forever. So here's my question. At what X value do you have a Y value of 0?
0.
And that would be 0. That would be 0 for that. What X value does f of X equal 2?
-2 and 2.
All right, so Patrick, here we go. Here's 2 on the Y-axis, right?
Yeah.
Yeah.
So imagine a horizontal line going straight across. Anything on that line would have a Y value of 2. So she went over here to this point first, it was on that line, right? And
Yeah.
she went straight down and said, okay, so that was -2 for that X. Because it's on the line. And then if you look to the right, you had this point sitting on that line. So she looked straight down and that X value was +2. So if I said, so Patrick, let me hit you with this. What X values does f of X equal 1?
That's 1, 1, or it's -1, 1.
Bam, there you go.
Yeah. I guess I think the question I have is if we go back to the other page, and I guess I don't understand why it's, because I understand like here where we're looking at -2, 2, -1, 1, stuff like that. I didn't understand when we're talking about X, because X goes left or right because it's on the horizontal line. We were actually going up or down, I thought, on the vertical line, which is Y.
Check this out. Although this X-axis is horizontal, all the X coordinates are straight up and down. Anything on this vertical line has a X value of -5, okay? This would be -5, 0, -5, 1, -5, 2, -5, 3, and so on. So the lines on the X's go straight up and down to where these Y's, although they're on a vertical axis, Y values are horizontal with the same values. So this would be 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, and so on. So that anything on a horizontal line has the same Y values. Anything in a vertical line has the same X values, okay?
Okay, I think I got it.
It's not bad, it's just getting used to, I see what y'all are saying, because the X's are horizontal here, but it's just the axis is horizontal. All the vertical lines are like X equal -5, X equal -4, and so on. So let's go back to that graph. So for this one, f of X equals 3. I went up to 3 on the Y-axis, and I looked at that horizontal line going left to right. So that the left point y'all said was what, -4 it looks like. Because if you drop down, and the other one on that line, if you drop straight down, was at 2. So I got one more of these kind of problems I'll do with y'all, see what y'all do on it. Now,
Is Math Lab gonna want us, we're just gonna go ahead and start with like the larger number, the one closer, you know what I mean? Like, what if we would have did -2, -4? Would they like that?
Yeah, the only time you gotta worry about order on these numbers is if it says put them in descending order or anything.
Oh, okay, okay, yes, yes, I remember that too.
So I could have went -2, -4. I could have put my domain in any order. I just sort of go left to right on them. Now, when I do the range, I usually go from the smallest Y value upward. So y'all, what's the first range number I'm gonna put in if I wanted the smallest range value? How about this? What's the smallest Y value we have?
Isn't that 2?
It's gonna be at 2, because that's the Y value at 2 of that vertex point, right? All right, going upwards, what's my next Y values?
3,
So 3. All right, next.
4,
And you notice on these, although you got 2 points at 3, 2 points at 4, we don't have to list repeats, okay? And then my final number.
5,
So y'all, we wasn't looking left or right on that. We're just looking on these horizontal lines coming off of that Y-axis there, okay? So then you would put those numbers in. Let's say you're gonna check that. So let's go look at the next one. So that one, notice I use points. The next one is gonna be solid lines. So let me make this one larger. So this will be for y'all. What is f of 3? What is the value of this function when x is 3?
2,
All right, let me see. I was trying to see if anyone was trying to chat us. So no one's on chat. So y'all see how we got a 2 on that? Go to the x axis, go right on the x axis till you get to 3. Go straight up, and where you hit that line has a y value of 2. All right, so this one I'm going to help y'all on. Y'all see how these arrows go both directions. So let me show you what they're doing here. And y'all say they got this going both directions. When we're dealing with lines like this, and to the left on the x's, if you go left, it heads towards what we call negative infinity. If you head right on the x-axis, it heads towards positive infinity. Well, y'all, the y's do that too. If you go down the y-axis, you head off towards what we call negative infinity. These numbers just get smaller and smaller. If you head upwards on the y-axis, you're heading towards positive infinity. Those values get larger and larger. Well, y'all, these arrows mean that this line goes forever to the direction left. It goes forever in the right direction. So when we get a line that covers every possible x value, we call that all real numbers. In interval notation, we'll learn this later. We call that negative infinity to infinity. Y'all might have seen that before, this infinity, right? So the domain would be all real numbers on this one. My range, can I put all real numbers on the range?
no,
No, because the range goes up both directions. It does not come down into the negative numbers, right? So say this was 0 on the axis. Since I don't have any negative numbers for my range, I would say that it was for y such that y would have to be greater than or equal to And notice, what's my smallest range value? When it's
0.
it'd be the 0, there you go. And then I would shut that. So this step builder notation, you tell it what the variable is, and then you list the conditions. This little bar here means such that. So y is my variable such that y for my range has to be greater than or equal to 0. Now, if it went the other way, I'd have said it had to be less than 0, okay? So let me take y'all back to this page. So y'all, knowing what we just said about the domain, what is the domain of this graph? Would y'all choose A, B, C, D, or E?
Real numbers.
Oh, you said all real numbers? I think I heard it, all real numbers.
Yes.
Yeah, so remember the domain, the arrow goes left out the x-axis, it goes right down the x-axis, so that has to be all real numbers. All right, Patrick, I might pick on you on this next one, all right? I'm gonna see,
All right.
I'm gonna see if you got this. I want any x values for which f of x equals 2.
I'm not 3 or a,
So
yeah,
3,
isn't it 3 in both?
so 3 is perfect. And then what was your second one?
Well, if x value equals 2, I think that's the only place it intersects is at 3.
Okay, but what about the right side of that arrow?
I'm still thinking, okay, I'm getting confused. So I guess it would be, by chance, I was looking at the right, okay. So in that case, it'd be 7.
There you go, 2 and 7. I mean,
Yeah.
2 and 7, perfect. So on the left side of the arrow, he went to 2 and went down and got my 3. On the right side of the arrow, it also had, it's going right over that 2, right on that y-axis. And he went down and got me a 7. There you go. All right, y'all, then it's going to do a range on us. So for the range, y'all tell me if y'all would pick A, B, C, D, and E, and what you would put in the box if you're putting anything in the box. So the only one you got to kick out for sure for the range is D. Because D is only using the greater than, and range always has to be greater than or equal or less than and equal.
Is it B?
Okay, B, there you go. And what number's going in that box?
5.
Now, what's the smallest Y value? Remember, 5, that's the X value, right? So what's the Y value of that formula?
Would it be 1?
0.
Yeah, it is 1. I think so.
Well, y'all think about this. That graph is touching the X-axis, right? So if it's touching
Yes.
the X-axis, that means the Y value is what?
0.
0. There you go. Okay. So then y'all would check that. So then I'm gonna go back to my pad and talk about functions. So let's go. So y'all get more used to this stuff, I think. It's just tricky getting used to it in the beginning, but y'all just keep hitting that similar exercise and it'll give you different problems and you can sort of really practice a lot on that, okay? Now, we're going to find the domain of a function. So y'all, here's the thing about the domain of a function. The domain of a function must contain all X values that can be plugged into the function and have real number answers. Or you can consider that your outputs, okay? So the domain of a function has to contain all X values that I could plug into my function and get an answer out of, okay? So at this point, there's only one thing that I can't do that won't give me a real number. Because y'all, a real number can be whole numbers, it could be integers that are positive and negative. Fractions can be real numbers, decimals can be real numbers, all that fun stuff is real numbers. So let me ask y'all this. Can I do that? Can A be any number and me divide by 0?
No,
No,
still be undefined, right?
undefined. So remember, anything divided by 0 is undefined. Which means that's the only thing that will not give me a real number answer because it's going to be undefined, okay? So my domain cannot include any x's that create this situation, okay? So finding the domain of a function. So if we have fractions, we must exclude any numbers that make the function undefined. Okay, now we're only worried about fractions because if I got stuff that's squared to the second power, well, I can square any number. Cubing, I can cube any number. Absolute value, I can take absolute value of any number. The only thing I can't do is put zeros in the bottom of a fraction. So what we do, if we have a fraction, here's our steps. Now remember, I'm only worried about that denominator equaling 0, right? The top can be 0. 0 divided by 3 would be 0 and so on, okay? So the top can be 0, just not the bottom. So what I do on those, I set the denominator equal to 0. So by me setting it equal to 0, I'm then going to solve it for the variable. You know, once I got x equals 5, that means 5 is the only number I exclude from my domain, okay? So once you solve for that variable, you're just going to exclude any solutions from the domain. And then I'll show you how to do that. We're going to use the set builder notation. We list our variable, which they use x in here. We put x as a real number. And x is not equal to, say, whatever number we get. Okay, so this is what we call set builder notation expanded for functions. We list the variable. Remember, the bar means such that. And then here is our condition. So what this would mean, any real number I can put into my function, it will give me a real number unless I put a in. So say I had an a on the bottom of my fraction, a minus a gave me 0, which made it undefined, okay? So we're gonna play with some of these. Now, if the function is not a fraction, then the domain is all real numbers. So y'all, that'd be the little set builder parentheses. Let me put that down just a little bit. The variable x such that x is a real number. Now they'll have all these written out. You're just going to be picking A, B, C, D's on these. So x is a real number. So if it works for all x, you got x is a real number. If you got to exclude anything, you're going to put x is a real number and x cannot equal whatever that number is, okay? Oops, all right. All right, y'all, so here we go. Let me get my problems. So on these examples, we're going to find the domain of the function. So these will start with y'all's number 3. I have f of x equals 13 over x minus 3. All righty. First thing I noticed, this is a fraction. Now, this is a fraction. Oh, I'm getting static back from y'all. Let me see. I think it's better. All right, since this is a fraction, does it just mean, are y'all hearing feedback?
Yes.
It's feedback from someone who's got their mic open.
Is someone got a phone on the end? All right, so let me try now. All right, y'all. So since I have a fraction, I'm going to have numbers I got to exclude from my domain. And I have that variable in my denominator. So what I would do, set x minus 3 equal to 0. Because when we set the denominator equal to 0, we're forcing it to give us the values that would make it undefined. So y'all solve this. Y'all got one step.
So you add 3 to both sides, and it'll give you x equals 3,
X
a positive 3.
So that means 3 is the only number I can't put in there, because when you put 3 minus 3, you get a 0. So you're going to come in and say x such that x is a real number and x cannot equal R3. So good job. So let me let y'all do some of these that I'm about to pop up for the homework. All right, y'all should be seeing question number 3. F of x equals 4 divided by x plus a. So our question is, what is the domain of f? So y'all got what? A, B, C, and D.
B.
Oh, what y'all just say?
I said it'll be D.
D is in dog?
Yes, sir.
That's it, right? Is the only number, if you set that bottom equal to 0, you subtract 8 from both sides, you get x is -8, which means for my domain, x is a real number, and x cannot equal 8. Good job. Anyone else want to try one of those? Let's see, I can go back to it and get a repeat. All right, y'all, A, B, C, or D?
D.
Oh, that's sort of sad. It gave us D again, ain't it? But yeah, -11 is the only number you can add to a positive 11 to make that equal 0. And if you had set it equal to 0, you're just subtracting 11 from both sides. All right, so I'm gonna move on and see what y'all do. Find a domain. P of x equals 2x minus 9. A, B, C, or D?
C. Is it C? Okay, I don't know why I couldn't even see all of that. Wait. Yep.
So y'all are going with,
I would say C.
yeah, because y'all guess what? There's no fraction there. So since there's no fraction, there's no way to make this undefined. And since there's no way to make it undefined, all real numbers work. P of x equals x squared plus 5. What is my domain?
D.
So let me see. D again, is that what y'all said?
Yes, sir.
Yes.
Yeah, no fraction. No matter what number I put into that, I can square it, add 5, and get an answer. Good job. So this homework's not gonna be too bad on y'all unless you get a fraction. Oh, well, here's a fraction. I'll let y'all work that one out and see what y'all get on that, okay?
Is it C?
Yeah, I was gonna say C.
See, perfect. Set 4 minus 5x equal to 0. Subtract 4, then divide by that -5. So all them negatives will make that positive. So y'all are good. C. Now they try to throw some curveball answers in there. And look, they try to mess you up with D. They got the 4/5, but look, they're using that greater than. So watch for them to do tricky stuff. All right, P of x equals absolute value of x minus 10.
That's A.
A.
Oh, y'all getting quick now, so y'all are figuring it out. If it ain't a fraction, we're going with a real number. Yeah, there's no restrictions on absolute value. I can put anything in that, right? P of x equals x to the 3rd power minus 6.
D.
Yeah.
Okay, oh, they didn't even put an alphabet there, because we're going with, I guess, the 4th dot, right? That's sad, they didn't even put our letter choices. And especially y'all, if you look at these numbers, well, 0 greater than 0 would be 1. Well, I can cube a 1 and put a -6 in it. But it also works for negative numbers, so they're not even including those. 6, well, I can cube a 6 and subtract 6, and same thing with that 0. So All right, so that's gonna be y'all's homework for 2.3. Did y'all have questions on that? Because I'm about to review something else if you don't. So remember, we're only worried about fractions. And the fractions gotta have a variable in the bottom for me to really be worried about that anyway, okay? So let's play a little review. And this is really to get y'all ready for what we got coming up Wednesday. So x plus 2 times x plus 5. Do y'all know what I'll use to solve this?
Four.
I'm going to FOIL. So y'all, let me tell you, FOIL works when you got two binomials. These are called binomials because they both got two terms each. But when you multiply two binomials, we FOIL. So when multiplying two binomials. So FOIL is a way that you can remember that you got to multiply 4 times, and it sort of gives you a pattern. So, and you're really doing the distributive property twice. Now notice, parentheses next to parentheses imply multiplication, right? So y'all watch what we got. F is for the first one from each parenthesis. So y'all, when you multiply variables, you add those exponents, and since these x's do not have exponent, you treat them like 1. So x times x, 1 plus 1 would give me a x squared. Which also means, written like this, I'm multiplying 2 x's, right? All right, then you take that x in the first parentheses and multiply by the 5, because that is the outer two most terms. So how about that? I got an x times a 5. That'll give me a positive 5x. So y'all, basically, I distributed that x through the second parentheses. X times x gave me x squared. X times the 5 gave me 5x. So then, the 2 and the x, these are what we call the innermost two terms. They're the innermost. So we do 2 times x, and we get a 2x. So basically, I'm starting to distribute that 2. So now, the L is the last one from each parentheses. So you would do 2 times 5, and that would give you a positive 10. So basically, take the x, distribute it through the second parentheses, then take the 2 and distribute it through the second parentheses. Once I've done that, I have 4 terms sitting here. So let me ask y'all this. Can I simplify this further?
Yes.
Yes, you can combine like terms.
Okay, there you go. So y'all must be talking about that. 5 and 2 in the middle, those are like terms. Now, I can't change the way variables look when we add and subtract, okay? The only time I can change them was up here when I multiply. So then just bring down the x squared. What's that? 5 and 2 give me 7 x's. Plus my 10. At that point, we can't go no further. Final answer. So Patrick, did he show you that?
We went over it a little bit, but I really appreciate you just covering that. That's a huge help.
Uh-huh. Now I'm going to multiply more stuff. I'm going to FOIL for a little bit, and I'm going to show you some of the. So I'm going to FOIL this one. But this, anytime you have like an x plus 7, x minus 7, we call these conjugate pairs. I sort of remember that because prison term, they used to do what, conjugate visits? They had a male and a female, so that's sort of kind of mean that. But anytime you foil stuff like this, it's conjugate pairs, you're gonna see stuff sort of cancel on it. So y'all, let's go. We got a x times an x will give us what, an x squared. Take that x times that -7 would be a -7x. And also the trick on these is just keeping up with these signs, okay? So we're done with the x, so now let's distribute our 7. 7 times x is a positive 7x. And then that 7 times -7 gives me a -49. So all 4 steps on that one are being multiplied. Now, hang on a second. All right, so y'all never wanted Chihuahua, okay? All right. All righty, so here's the thing. What happens to this when I simplify?
They'll
But we
combine
take out,
like terms.
Canceled out the 7x.
yeah, we take
Yeah.
out the middle section, yeah.
And
So
what-
it'll be
But can't you take it one more step too? So we got x squared minus 49. Isn't there a way to break that down to like, because 7 times 7 is 49.
Well,
I'm overthinking it, but
what you're looking at, so this is the final answer if I was foiling this. But if I had started with x squared minus 49, I could have factored it back into this.
oh, okay. Okay.
And we'll look more at factoring later on in life, just a little bit further. But yeah, we'll take these answers and go backwards to get this kind of stuff.
Okay, cool.
So let me see what would y'all do to this. X plus 3 squared. Now, this is where I get a lot of mistakes is when people see this. This
Well,
is
can you,
a binomial squared.
can't you just break it into x plus 3, x plus 3?
That's what you got.
Okay, okay.
The biggest mistake, people see exponents, they want to distribute it and get that an x squared. And they didn't want to distribute to the 3 and make that a 9. So they end up with x squared plus 9, which is wrong. You gotta write that twice your first step. It's foil in disguise, okay? All right, then what you getting? You want to multiply x times x? Give me-
X squared.
Squared
Plus
Plus
6x
3x.
plus 9.
So 3x and then what, 3x? And then y'all said 9, I think it was. Now notice, when you square a binomial, you get like terms in the middle, but guess what? They got the same sign. So these ones will not cancel like the conjugate pairs do. It sort of doubles the middle. So you bring down your x squared. Well, 3x and 3x double to give me what, a 6x? And plus a 9. So this would be a trinomial. In this form, those are binomials, okay? So question on that. The point is not bad once you get used to it. Just take that first one, zip, take that second one and zip. So let me play with y'all a second as far as foiling, okay? What if I had x to the 4 plus 3 times x to the 4 minus 2. So let's start with the x4s. What will I get when I multiply x4 times the x4?
X to the 8th.
X to the 8th. Remember we.
Find x to the 16?
No. All the rule for multiplying variables, when you multiply, say x to the a times x to the b, that answer will be x to the a plus b.
Oh, okay, cool, thank you.
So add exponents on those. Now, x to the 4 times -2 is what, a -2
X4.
x to the 4. There you go. So a number cannot change exponents, but a variable times a variable can, okay? All right, then you come in, you're gonna do 3 times that x to the 4. So what's that, a positive 3 x to the 4? And then what are y'all putting at the end?
-6.
-6, because we'll take that 3 times that -2. So I wanted to show y'all, that's why I like to do these, because I refresh y'all on when you multiply variables, we're adding those exponents. So can I go further?
Yes.
Yes.
There you
Can you
go.
hold for 1 second? Just 1 second.
So that'd be what, 1 x to the 4, and then minus my this.
6.
And y'all, that's good, because remember, at this point, all we could do with them 4s, that 8, nothing matched it, so we had to just bring it down to 6, nothing to add or subtract to, just bring it down, okay? All right, let me refresh y'all on one of these. Y'all seen this kind of problem already in support, but I just want to do it again just to get you good. Now, if this was an adding in the middle, if this was plus, I could just match up stuff, add them and be done. But we got subtraction here. And that subtraction, if you remember, has to be distributed through all these parentheses. Anything that follows the subtraction that's in parentheses has to multiply by it, and then you get out and do whatever. So if I'm gonna subtract these, first thing I'm gonna do is remove the parentheses. So there's nothing in front of here, so I can drop the first parentheses and bring everything out how it looks. Here's where we gotta start doing some work. You treat subtraction like a -1 when you get rid of parentheses, and you're basically multiplying everybody by that -1. So right here, you got this negative times a negative x squared.
So that's positive x squared, right?
Positive x squared. All right, what's next?
Then we do the same thing, so we're doing the -1 across, that just, it's 1, so it's gonna be the same digits, but it's gonna be a negative because we're doing a positive negative, right?
There you go. And then at the end. So,
-8.
so negative changes all the signs into parentheses when you come out of them, okay? So now, what y'all doing next?
Can't we simplify it, like, do the
Combine like
positive,
terms.
Yeah.
yeah, like positive 3x to the -7x to do a,
So the x squared matched, and you had what, 3 of those? How about this one, 3x minus the 7x?
so -4x.
-4x, and then -10.
And then the -4 and the -8, y'all said was
-12.
-12. Can't go no further, so we're done. Now, you won't see this kind of stuff that I'm doing on this review tonight, but you're going to see it quite a bit Wednesday night, okay? So let me go into, I'm going to play a little bit with the exponents. So y'all, anything to the 0 power equals what?
Undefined.
0.
Oh, so I'm getting undefined. Remember, I don't have a fraction, so I don't have to worry about undefined.
It's 0 because
Oh, so
if
it's
it's,
calculator with you. So let me go to my calculator. So how about, what would 5 to the 0 power be? Oh, I didn't pull mine up, so. So for example, what if I had 5 with the exponent 0? Oh, none of y'all got a calculator?
It's 0.
Oh, your line.
1.
Oh, who just said that?
Sorry.
It is definitely 1. Y'all watch this. 5. Hit my caret key to put my exponent 0 in, and 5 to 0 is 1. 7 exponent 0 is 15. Exponent 0 is.
Oh,
Now watch this. I can put my negative numbers in parentheses. -6 to the 0 power. Guess what that is?
-1.
Oh, my calculator said +1. Remember, when you're dealing with exponents, if you got a negative number, you gotta put it in parentheses, okay? Now, if I had something like -x², then I would keep negative. So anything to the 0 power is 1. Now, I'm gonna prove this to you. What if I had this? X to the 7 over x to the 4. What would
X to the third.
What did you just say?
X to the third. Because you subtract the 7 and the 4.
I subtract those exponents. So the rule for that would be x to the A over x to the B equals x to the A minus B. So remember, I gave you the one while ago for multiplying, you add, subtracting, the top exponent minus the bottom exponent. So she did 7 minus 4 and gave me 3.
what if the exponent on the top digit is lower? What if it was can you have like a negative exponent, like x? If it was x to the 4th over x to the 7th.
So here's the thing. This one I call Dolly because it's top heavy. This one I call J-Lo because it's bottom heavy. So if it's bottom heavy, if it's bottom heavy, the variable will stay in the bottom. So you always take the bigger exponent, which is 7 here, right? And subtract the smaller exponent. So 7 minus 4 still gave me a 3. So y'all think about this. Since my variable is in the bottom, what must I put on the top?
1.
A 1. Okay, so bottom heavy, the variable stays in the bottom, Patrick. Top heavy, it's going to stay on top, okay?
Okay.
Now, I'm about to prove why a to the 0 equals 1. So x to the 5 or 5th power divided by x to the 5th power, what will that equal?
1, right?
Yeah, anything divided by itself is a 1. But what if I use this quotient rule? We call this the quotient rule for exponents because you're dividing. If you use this rule, 5 minus 5 gives you 1. 0, right?
Okay, all right.
But we already know that this x to the 5th divided by x to the 5th equals 1, which means x to the 0 by default has to equal 1, okay? So hopefully that sort of showed y'all that anything divided by itself is 1, but if you use that quotient rule right here that I gave you, you would get x to the 5th minus 5, which is x to the 0. And since we know that this has to equal 1, that means x to the 0 by default has to equal 1 on that, okay? All right, so y'all don't have to know all the exponent stuff right off the bat, okay? But in the future, I will ask y'all stuff like this. What's 7 to the 0 and all that stuff, okay? Now, Patrick, technically, x to the 4 over x to the 7 would equal x to the what? -3. I think you was telling me earlier.
That's what I thought. That
Uh-huh.
was my interpretation, but
But here's the thing, we don't like exponents being negative. So anytime we got a negative exponent, we flip it or put it to the bottom. So we would treat this like it was over a 1, right? If there's not a number under something, it's a 1 automatically. So to make the exponent positive, you flip it, which will give you the 1 over x, and then you make the exponent positive.
Okay.
So that's why I just say, if you don't want to mess with negative exponents, you just take the larger exponent and subtract that smaller one from it and leave that answer where that bigger exponent was at to start, okay? Okay, so that's probably enough review on y'all tonight, right? So you're definitely going to start pulling Wednesday. We're sort of going to do some adding and subtracting Wednesday and get a little more algebra for y'all, okay? All right, y'all, so let me stop this share and see what questions y'all got. So tonight, your homework's going to be 8 problems, just like I did. You're going to have 1 with the dots on the graph. You'll have a graph with the lines. And then you got 6 questions there. And remember, on them questions, we're looking for fractions because those are the only ones that are going to give us work. Everything else, if it's not a fraction and you're finding that domain, y'all said those were what?
Those are just real numbers then?
All real numbers. There you go. So it's not going to be too bad. Then really Wednesday's not too bad. And then y'all remember next week, I won't see y'all till Wednesday. Monday, we won't have class because that's a holiday for Labor Day, okay? All right, trying to check my row real quick here. Okay. So I think I lost a few students today because something about their pay wasn't set up or something, so maybe they'll get back in. So do y'all have questions over anything?
Is there a difference, or what is the difference between the TI-83 plus and the TI-84 plus calculator?
Nothing. I mean, you got what, a TI-83 plus?
Yes.
Yeah, it just, the plus means that sometimes it's got a little more memory than a regular TI-83. But as long as it's any type of TI-83 or TI-84, you should be good to go. Let me see something.
But you said that like I could come up there and you would do my programs, right? Because I also have, remember we talked about that, the 83
Yeah,
plus?
yours was old and just had that push-in pin on it, remember?
Yeah, mine, yeah.
Uh-huh. So yeah, yeah, that one I gotta do at school. If it's got
Okay.
the USB cord with it, you can plug them to the computer and download programs when I send them. If
Okay.
you got the little, I call it a pinhole looking connector.
Yeah.
Then I gotta hook it to my computer to get you fixed.
The bookstore advised me to get this one, just so you know.
Okay, so hopefully they hooked you right. Most of the ones in the bookstore have both where I can go either way on them, so.
But I don't remember having a cord to it.
Me either.
And they told me to get this one for my class. Like I showed in my classes. He said, oh, you need this one.
Do you have the 83?
I do. I have a TI-83 plus.
Okay, me too.
She's
Yeah,
got,
they give me the 84 and it has the cords to it.
Yeah, I got an 84 CE apparently.
CE is color enhanced, it's good.
It's all they had on Amazon that I could get within a month, so that's what I had to get.
So the CE is color enhanced and it'll work. It's the newest model. So this is the TI-84 plus.
Fancy pants.
Now, there's a cord that hooks into this little USB port on the calculator.
Yeah, it's mini USB.
That will allow you to hook it to the USB on the computer and download my programs. Now, if you got the older TI-83, at the bottom of it, there's just gonna be a hole. A little hole to put a pin in. That's the way I can download calculator to calculator if you don't have the USB on them, okay? So, yeah, if you don't have the USB, I'll physically have to do it. If you don't have the cable cord, the USB to connect it to your computer, you might can find that on Amazon, or you can come up to the campus and I'll program them in for you. So if you don't have the cord or your calculator's too old, I'll have to physically, and I'm on the main campus, like Monday, Wednesdays, and Fridays. But yeah, so let me show what I'm talking about. When I hit program on mine, these are some of the programs I'm going to send y'all. So I'm going to send y'all one called like the quadratic formula. So when you use the quadratic formula, it saves y'all from having to factor and do the quad by hand. So I can just punch in 3 numbers for A, B, and C, and it gives me answers.
Are the programs like macros then?
Do what now?
Are the programs like macros then? Like where it's you tell it how to do a series of commands, but we only have to touch 1 or 2 buttons and it'll do the rest of the commands for us.
Yeah, it's a program some of these programs, I did some of them and then other people have done them.
Awesome.
So yeah, because once we learn the quadratic formula, the next test material, we got to use the quadratic formula to help us find zeros and stuff. But we don't require you to do it by hand after we've done sort of went over it and test over it. So that's when you love these calculators, is that the ability for them to download all these programs, you know what I mean? Y'all remember stuff like the slope formula?
Nope.
M squared plus B.
Yeah, the slope of a line, is the, so y'all might remember
I mean, not M
the
squared, but
slope of the line.
MX plus B, my bad.
But remember, the formula for the slope is y2 minus y1 over x2 minus x1. Y'all remember that?
Yeah, I do.
Maybe. So,
Man, I did all this stuff like in 2001. I don't remember
Right.
any of it.
Right. So, yeah, but you're gonna learn all that. We don't mess with slope a whole lot, but we mess with like vertex formula, quadratic formula, and fun stuff like that. Alrighty, so yeah, like I said, depending on your calculator, depends on whether you can do it off the computer or not, okay? But when I send programs, I'll send directions also how to put them in. All right, y'all, so I'm gonna stop our recording for sure.